Okay, hi, welcome everybody to this session. Thank you for taking the time out to come and join us. This is session DBI 222, Big Data, Small Data and Data Visualization via Sentiment Analysis with HDInsi, which is a bit of a mouthful. But what we're intending to cover today, we're looking at processing unstructured data using Microsoft's Hadoop platform, HDInsi. And we're going to do that to add some sentiment analysis to it. And we'll get into what sentiment analysis is for those of you who aren't 100% across that slightly later. We're then going to take that and we're going to enrich it and model it in Power Pivot, and then we're going to visualize it with Power View. So we tick all of those boxes somewhere along the way. But first of all, some introductions. It says who am I, but it's actually who are we. I am James Beresford. This is Gavin Russell-Rockcliffe. I have over a decade of Microsoft BI and DW experience. I've picked up a bit of hands-on big data experience over the last year using some high-speed projects and some high-volume projects. I also blog at BI Monkey, and I tweet at BI Monkey as well. And at this point, I'll hand over to Gavin to do his introduction.
Thank you so much. So, good morning, everyone. Good to see you all. Yes, similar to James, I've been involved in the BI space for quite some time now, for better or worse. With a key interest really in analysis services and data visualization is really what gets me excited about BI, to be honest. And good to see how all these technologies are slowly growing up and kind of merging to become a good product for Microsoft. Yeah, and feel free to join the conversation at GavinRR. And when we're not presenting at TechEd, I look after the Avanad's BI practice across Australia. So what do we have to speak about today? Well, basically the real premise underneath our session is a simple question. And the simple question is, how can we understand what our customers are thinking and what they're saying without necessarily going out and asking every single one of them one at a time? And I think you can quite clearly see that if we can answer a question like this with some certainty, both our companies and potentially our clients' companies could get quite a competitive advantage. It's not an easy thing to necessarily be able to do. So as James has sort of alluded to in that initial intro, we're going to basically step through the process of getting that sentiment analysis solution in place. So all the way from understanding a bit of what sentiment analysis is, what big data really is, we'll lift the lid again and just kind of unpack some of the rumors. Then we're going to go in and actually build a solution that processes how many gigs of data, James?
35.
35, there and thereabouts. 35 gigs of ridiculous posts over about 7 or 8 years, and then actually visualize them through Excel and Power View, and hopefully show how all of these components fit together to tell a fairly good story. But it's a stat that always depresses me about sessions like this, is that I've read that people like yourselves, and like myself when I'm in a TechEd session, only tend to remember 2% of what we hear. So I'm not depressed by that. The other 98% I'm sure will be interesting. But the 2% we'll remember by the time we go home. And what I'd like for you to at least walk out of here remembering is that the Microsoft stack can answer crazy questions like the one we're trying to propose today, that we can understand sentiment analysis. But also it's far more powerful than that. So we can unpack other scenarios that using traditional integration services or traditional data warehousing techniques, we may not be able to do as easily today. So I think, we can and we can do more are my two thoughts I think we should be walking out here thinking today. So, sentiment analysis. Thanks, James. Was that a selfie?
It's a UE.
Sorry, by the by. So, sentiment analysis 101. Right. Really, what is it that we're trying to achieve through sentiment analysis? Well, it's really a process at the end of the day. And the output of that process is we're trying to understand or infer emotion behind what people have written or behind what people have said. Now, never an easy thing to be able to do. I think we've all misread the occasional email because of hidden tone under the covers, right? It's not an easy thing to automate, but that's the bold aim we're setting out to achieve today. So let's take an actual example. So like most of us, we're all staying in a hotel nearby. So let's assume we get to write some hotel feedback at the end of the week. And our hotel feedback looks something like this. So I had a fantastic time on holiday at your resort. Not that TechEd is a holiday. The service was excellent and friendly. My family all enjoyed themselves. The pool was closed, which kind of sucked though. So that could be, what someone would potentially write as part of their hotel feedback. Now, who would say that would be overwhelmingly positive? Overwhelmingly negative? Somewhere in the middle, there and thereabouts, kind of lukewarm, right? So it's there. So how would we automate understanding, pulling out sentiment from this? So our starting point, and the model we're going to be speaking through today, is to basically start with a list of words. Okay, as simple as that. And obviously focused around English because I'm My English is better than some other languages. And taking keywords and applying a positive or a negative score to those words. So let's call this our dictionary. Okay, so words like great, fantastic, awesome would be positive words, you'd think. Words like it sucked, it's awful, not so good would be negative words we put in there. So, and just it's how we build in our model out here, really, is we're basically assigning a 1 for positive words, a -1 for negative words, and everything else, so those nondescript words like and the and whatever it is, many, all those sort of words, we ignore. Because as you'll see during the course of the day, that 3.5 terabyte or gigabyte of text has a lot of words in it. So obviously if we can strip out a lot of the noise, we can get to the words that really matter. So we start with our dictionary. We assign 1s and -1s to the positives and negatives. We then go in to that piece of feedback that we're trying to analyze. Okay, so whether it be a call center record that's captured or hotel feedback. And in this case, we go in and highlight the words that we've deemed to be positive or negative, and greens and reds highlighted up top there. If we then strip that out into, let's call them the words that matter from this feedback, we get 4 positive words and 1 not so good word from the pool that was closed, apparently. And then through a series of incredible high-speed computation and mathematics that I'm not going to go into today, we can then count an overall sentiment score. Simple, yes. And to be fair, probably a little bit too simplistic. But for the purposes of today, what we're really trying to focus on is the underlying technology and how we can go in and actually strip out the words and start building the sentiment scores. For those that want to get more into this, because there's actually quite a deep science under this, absolutely recommended going and looking up a guy called Bing Louie, who's a researcher out of the University of Chicago, who's written some great papers on the space and all around how this works and how nouns are described in various ways and how you can build up these models in a deeper way. But yes, for the purposes of today, we're keeping it fairly simple to put the spotlight firmly on the technology under the covers. So James, if we believe Gartner and all that, all the write-ups, all the sentiment analysis sounds like big data to me. What's your thoughts?
Well, it is big data, and it sits along one of the very many axes of the 3 Vs, which I'll go into in a moment. So because big data is one of those big bucket terms where everyone in marketing is throwing it around and going, I've got some big data here, and I've got some big data there, and this is big data, I want to clear up just a few basics so that we know what we're walking into in this session. So the definition I've gone to, and I apologize for the sheer number of words on the screen, is the Gartner definition. So the Gartner definition has 3 Vs. Volume, variety, and velocity. So volume is pretty straightforward. Volume is just, there's tons of this stuff. So we're talking about eBay's transactions, we're talking about credit card transactions, mobile phone call records. There's just tons of this stuff, and your traditional data warehouse can't really manage those kind of volumes. The next one is variety, and that's the one we're going to focus on today. So that's the stuff that's too complex. So social media posts, customer reviews like we were just talking about, even transcribed call center records where automatic transcribing software has picked up what people are saying to the call center operators and capturing that in the database. And how do you analyze that as well? And again, that's not something that sits in our traditional DWBI world. And then the last piece is velocity. So the stuff that's just coming in at a pace that our warehouses can't cope with. Sensor data, live web traffic, mobile phone usage, GPS data, all that stuff that ticks through in the millisecond range. And again, we can't handle that with traditional technologies, so we need something new. And if you went to the big data architecture session yesterday, you would have seen HDInsi, and that's Microsoft's technology that handles the velocity. Volume and variety is handled by HDInsi, and variety is the one we're going to look at today. Now, the other term that I want to clear up is what is Hadoop. And Hadoop is actually, it's just a file system. So what you're seeing up here is actually how a file gets into Hadoop. So at the top, we've got this thing called the head node. And actually what that is a server that says, right, I have got this file. Where is it? Where is it in my cluster of 1,000, 2,000, or 5 servers? Is this actually living? And then we've got the data nodes down at the bottom, in the middle. And that's actually where the data actually resides. So the head node just orchestrates where all the data lives on those data nodes. And when you're actually executing jobs on Hadoop, they execute on the data node. So the code gets distributed out to where the data is. And then at the bottom, I've got just a file. And if that was loaded onto the Hadoop file system, it would be replicated a few times. So it'd be thrown across a number of different data nodes. And the reason behind this is at the bottom here, it says that it's read optimized and it's failure tolerant. So what read optimized means is that if one machine's busy working, then there's another machine available to process that file on. We've got different places to look for to process that data. And the failure tolerant piece is, if you've got 2,000 servers, they're going to blow up. One of them is guaranteed to blow up every single day, and you need to be able to cope with that system. So Hadoop is a file system, and it's HDFS. So similar to NTFS or FAT32, it's just a very customized file system for large volume data processing. The other term you'll hear thrown around a lot is MapReduce. Now, I kind of roughly equated this into a standard data warehousing world as extract, load, and transform. So a map is a mapper. It's a piece of code that executes against the data that's spread somewhere on the files, on those data nodes. So if we want to just strip out the words from a piece of text, we'll send that code to each individual mapper, and it'll process particular files on that mapper, and then it'll throw it up and produce data at the other end. And that's the mapper process. That's the extract process. And then the load and transform is all those data outputs that come from the mapper are loaded and handled by a program called a reducer that just kind of aggregates, brings it all together, and does whatever transformation you need to add meaning to that data. And then it gets dumped out. So MapReduce, not really that scary. It's just ELT. But obviously this is a TechEd, so we're going to move on to actual technology. And what we're going to look at is HDInsi. So HDInsi, Hadoop comes in many very different flavors. I'm sure you've all have heard of Cloudera, for example. They've got their own distribution of Hadoop. Microsoft's distribution of Hadoop is called HDInsi. And all the distribution is just, it's different. The Hadoop is an open source platform, so there's lots and lots of bits of it. And a distribution is certain versions all packaged together, made to talk together, and then thrown on one box. And so that's what HDInsi effectively is. And Microsoft's put their own Microsoft goodness on top of it. So what are we going to cover in today's technical session? We're going to look at creating an HDInsi cluster. So going back to that earlier picture, that's going to be our head node and a load of different data nodes. We're going to load data into Azure Blob Storage, because again, Microsoft, they want to make sure that they're leveraging all their cloud platforms. Azure Blob Storage is their system for storing large volumes of data in the cloud, so it makes sense that their Hadoop distribution in the cloud can talk to their cloud storage. We're going to look at C# streaming, and that's just processing text line by line by line by line so that we can get some value out of it. We're then going to look at a thing called Pig, which is a language with a silly name that is there to enable you to enrich data and add some value to the raw data that's output. We've also got, we're going to look at Hive, which is a kind of data warehouse-like technology that will enable us to output the data. And that output route is through ODBC, which obviously then means into Power Pivot. And if you've got some Power Pivot, you've got to have some Power View on top of it. Okay. And probably some Power BI. Have you sneaked some Power BI in?
Well, let's just say we snuck a bit of power in there, and we'll leave it at that.
Okay. Well, yeah, actually, I'm surprised it's not called Power HDInsi, given Microsoft's current naming
soon
conventions. But anyway, so what are we doing? So we're going to create an Azure HDInsi cluster. So HDInsi is available as an Azure cluster. An Azure service, and it's launched from windowsazure.com. So if you are familiar with the Azure Management Portal, down the list of the services on one side, one of those options is HDInsi. And what we're going to do now is we're just going to actually go through and demonstrate building one of those clusters. So here we are in the Azure portal. And if I can, we can see here we've got our HDInsi option. So we're going to click on this and just launch ourselves a cluster. And it kindly tells us that I don't have any. So we're going to go and click and opt to create one. And so got to just do a custom create because we need to point it at some particular storage. So we'll give the cluster a name and call it TechEd Sentiment Demo. We have to pick the number of data nodes. I'm greedy and I want to get my stuff done quickly, so I'm going to bump that up to 8 from the default 4. I'm not going to mess with the HDInsi version, and I'm going to change the region to North Europe because it needs to match where the storage is. I need to just quickly create a cluster user, so the usual admin and top secret password.
Password 1, I believe it is, isn't it?
And that's what I'm going to keep telling you. Any social engineers in here, all my passwords are password 1. Honest governor. Okay. So enter our password. And then the next piece is then we're going to configure our storage. So we're going to use We're not going to create new storage. We're going to use an existing storage account that I have set up that's got data in it. I've currently blocked out the account name, got the default container set up, and I don't need any additional accounts, and click, we're going to go. So at this point, I'm just going to guess. I'm going to spin up 9 servers. I'm in fast forward mode at the moment. Timer starts 0. Who thinks this takes a day? 12 hours? 6 hours? 3 hours? 1 hour? Half an hour? Nobody thinks this takes any time. Everyone thinks it's going to take 2 minutes.
Everyone thinks it's instant, James.
Everyone thinks it's instant. Well, let's watch. So we're configuring the Azure VMs. So I'm not going to tell you what warp speed we're running at here. It's very busy down here. Oh, configuring HDInsi, so it's already got all the VMs set up. I couldn't quite figure out how to get a zapping timer going along the bottom here. And it's running in 16 minutes. So in the space of 16 minutes, I've managed to get 9 servers up and running and ready to roll, building some HDInsi stuff. So I'm just going to quickly connect in and just validate that everything's running as I intended. So it's a server in the cloud. It's just a normal Azure box, the head node that you connect into, so remote desktop in. Go through all the usual things, so you just tick yes, 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 yes to, because we don't really care, we trust Microsoft. Nope. Windows Server 2008 R2, it's a little bit behind the times. Top secret password goes in again. First user stuff, and boom. So we're in. We've managed to successfully set up a complete HDInsi cluster, remote into the box in the space of 20 minutes. Now, I was talking to one of my colleagues earlier who'd been attempting to set up their own Hadoop cluster, and it took a little bit longer than that. It's probably the polite thing to say. So the next thing we go, now we've got our cluster, we need to actually get some storage, some data in our storage. Now, actually, under normal circumstances, because of upload times, we'd actually put the data in first, but this is demo world, so I'm doing things slightly out of sequence. So as I've mentioned, HDInsi can directly reference Azure Blob Storage, so we don't actually have to go through the process of loading data into HDFS. So what we don't have to do is spin up our cluster and pay for it to sit there doing nothing, as we just try to shove data up through Australia's incredibly thin pipes. Into HDFS, we can actually get that done first. Data can be loaded using a variety of utilities. So there's commercial utilities, there's freeware GUI stuff, there's command line things from Microsoft. The one that I've particularly gone with is a creature called Cloudberry Explorer. So on the left-hand side, we've got a bundle of data. On the right-hand side, we've got my storage. I'm just going to quickly go into my data path. And again, this is just like typical folder operations, click, 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 click to manage getting through our Azure storage. Get into our data folder. Takes a little bit longer to get to the list back, but I've got most of my stuff already up there, and I just happen to know that I've forgotten this particular file, so I'm just going to drag and drop. And that's as complicated as it gets. So to be honest, the biggest challenge I faced with this was just the upload speed, which was a little bit on the sluggish side, trying to work with some of my home mobile connections. So, as I mentioned, so first of all, we're going to just check this. So Microsoft's told me that we can happily reference data in Azure Blob Storage. It's exactly the same as if it was data on HDFS. And so we can quickly check that just going into the Hadoop file system command line. So one thing we're going to discover here, Hadoop does not have a lot of GUIs. There's a lot of command line stuff. There's a lot of very scary and incomprehensible error messages when things don't work. Getting this demo up and running in the early days was quite entertaining for that reason. And because ultimately it's a very, it's born of Linux and Java. So Microsoft are moving it into the Windows Server world and the friendlier world, but it's sort of baby steps getting there to the point where we can just go click, click, launch job. So on our desktop, we have the Hadoop command line. So I'm just going to double click on that and make it a little bit more readable. So down here, oops, I've gone an overshot now. Let's go back. I'm going to have to replay. Okay, sorry about that. Okay, so back into the command line. So anyway, so down here we've got the command line. So I'm going to type here Hadoop fs-ls, which is effectively the equivalent of a dir statement in Windows. So it's just going to churn out what's in the directory. And what I'm doing here, I can now see that I'm typing out, I'm actually referencing the Azure storage vault. So this is my blob storage that I've loaded. I've got to mention my container, then I've got to mention there's the bucket that it's in, and just then go through and type out the whole at blob.core.windows.net and the folder structure within that so that I can get access. But bear in mind, these are completely separate beasts. So my Hadoop head node and my storage vaults, I've got no idea where they're stored at all. They could be physically miles apart or right next to each other in the data center. I've got no idea. But if I just type that and hit enter, it quickly spins off, and look, it's giving me the same directory listing, all the data that I had loaded that I could see in the in Cloudberry Explorer. So we've happily confirmed that HDInsi and Azure Storage are talking to each other quite happily. So we need a programming language to talk to Hadoop a lot of the time. So there is no nice toys like SSIS where we can just kind of build stuff up using a drag and drop operation, set a few properties, and we're off. There's a lot of hard coding involved if you actually start wanting to run Hadoop jobs. So Java is the preferred language for working with Hadoop. The platform's coded in Java. Most languages or interfaces that talk to it exist in Java. But C# APIs are being developed as part of Microsoft's implementation. Now, the problem there is there's always going to be a little bit of a lag because when stuff's released in the core code of Java, then Microsoft then have to play catch up and build a C# API that can then talk to that Java component. However, we can use C# to do simple Hadoop streaming jobs. So Hadoop streaming, as I mentioned before, is just the line-by-line processing of text. If I've just got a whopping great text file of 200,000 lines, I can step through that line by line and process it, and I can use any language I like. So I could use Python, I could use Ruby, I could use Java, or I can use C#. And so what I'm going to do today is I'm going to build a mapper using C#. And you can also use C# to build your reducers as well. But for the purposes of this demo, I'm just going to do a mapper. So first of all, we're just going to get into what kind of text we're actually going to be processing. So the archive that I picked up is called the Westbury corpus. And what this is some university has taken a dump of Usenet. And for those of you who don't know what Usenet is, it's kind of a precursor to forums. It's just like a free format email system where people could send messages to each other that were readable by anybody. It was quite wild. It's quite a lot of fun. And what they've done is they've taken about 6 years worth of data, anonymized it slightly, and compressed it up and made it available to the public. So I've got 35 gig of data, which is 26 million messages. And they look something like this. So they've got at the top, they've got Bob wrote, so Bob being the author, and there's kind of a fairly standard pattern, so I can strip out the author from this text. It's got some quotes here. So this is text that's quoted from the previous message. So anything that starts with a double chevron we know is going to come from a previous post. And then we've got the text. So I've got this, another one of your favorite answers, vague, meaningless, and unfathomable. Great line, no idea what it means. And then at the end of each text, they've got this block, end of document. So they can pick out, so each message they've terminated with this, so I know when the file ends, so that I can kind of scan through, go, that's a message, scan through, that's a message. So what I'm going to do next is I'm just going to quickly run through some screenshots of the code. I'm going to go through this fairly quickly because I know that code is a bit of a killer in any demonstration. But I just want to point out a few things that I had to put into my mapper in order to process the data that I think will be useful for you guys. So the first thing is a set of list of common words to ignore in the output. So as Gavin mentioned earlier in the sentiment analysis piece, there's some words that just don't add any value. Bad, good, excellent. These are all really useful words for picking up information. And the, not, with. They don't add anything, but there's an awful lot of them in any given block of text. So the first thing I've done is I've set up basically a dictionary of words to ignore in the output. So if I come across the, and, that, you, or a bundle of other words in that list, they're not going to be part of the output. And that actually reduces the volume of data that we have to work with on the other side. We also need to pick up a bit of metadata from Hadoop. So each of these archives has a file name, and that file name has the timestamp in it. So I need the timestamp in order to be able to put a time against these messages. So I actually need to be able to pick up the file name as I'm processing it. And so I do that using system.environment.getEnvironment variable. So if you know your C#, that's probably really useful. If you're like me, I just kind of cobbled it out of Google and got it to work. But we get things like map input file and map input starts. We get some information from Hadoop that we can pick up and we can bring into our mapper process. And then we need to read the file line by line by line by line. And we do this using the console readline method. So basically, it takes a text file from what's called stdin, and I don't really know what that means. But basically, it'll give you a block of a text file, and just go tick, 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 tick through each line and process each line within that file. And then at the other end, we use the console writeline method to then churn it out. And this goes to stdout, and that effectively writes a text file onto the Hadoop system, or in our case, into Azure. Similarly to the way that if you've written a console program, it'll spit stuff out in the console window.
So what we're saying, just for people like me, what we've done so far is we've taken that initial piece of text, which was all laid out in a crazy format, which SSIS and the likes wouldn't have been able to read,
Yep.
and basically put it into more of a tabular format that we can then go and start processing from here going forwards.
Absolutely.
Cool.
And we'll see a sample of the output at the tail end of this, so you can get a sense of what's come out the other side. But first of all, what we're going to do is we're actually going to build and execute the job. Now, an interesting thing, there's no need to unzip the data. So natively, when you're processing a Hadoop job, it knows the data if it's zipped and it's in a format it recognizes. You don't have to unzip it first, which is great because the 35 gig of data unzipped, I think it went to about 180. So again, if you need to upload 35 gig of data, that took me a while. I had to upload 180. You'd probably be watching a very cut down demonstration today. And similarly, it can output zipped. So again, when you're shifting data around your network, if you can compress it fivefold, that's a lot of network traffic that you've shifted off. And again, when you're in the big data world, the volume of data you're shoveling around really makes a lot of difference. And so this is a Hadoop job from the command line. So I appreciate this is probably not the most readable thing you will have seen today. So I'm going to very quickly tick through and just point out a couple of things, and hopefully that'll stick in your head. I won't test you on being able to memorize this later. So first of all, just from the command line, hadoop.commands. I'm telling Hadoop it needs to run a job. I'm telling it using the jar Hadoop streaming jar, which is Java archives a bundle of code, and I'm basically telling it that I'm doing a streaming job. I've got a couple of options set here to say, well, I'm going to compress the output, and I'm going to compress it using gzip. And I'm also telling it there's a file that it needs to reference in the process called sentimentv2.exe, which is my mapper code that I wrote earlier. I'm telling it that it's not going to do any reducing by telling it that there's no reduce tasks. I'm telling it the mapper is this code that I've provided, the sentimentv2.exe. And I'm telling it the input path, where on Azure it will find the input data. And on the output data, I'm telling it where to write it to, again, on Azure. So it's living entirely in Azure world. So let's get onto the server. So we need to go to the Hadoop command line. And I'm not going to hand type this. I'm just going to paste it in. And then I'll hit enter and watch it go. So when I hit enter, what it does is it spins up a whole bunch of stuff on Hadoop, that internal processing and orchestrating where it's all going to go. But the key bit that really matters is at the bottom it says map 0%, reduce 0%. So what that means is that the job has started and it's executing. Now, there's more than the command line for monitoring what you've got for your jobs or what your jobs are doing. There's the Hadoop map reduce status. So this is the job tracker. So sometimes you'll hear talk about the job tracker. This is the web interface. So let's just kill off the Internet Explorer 8 nonsense. Only 2 versions out of date. And we'll go into the job tracker website. So it's not the prettiest site in the world, but it gives us some basic information. So for example, we can pick up that we've got 8 nodes that the cluster's aware of, that it's working with. And if we scroll down to the bottom, we can pick out what jobs we've got running. You can see that it's got 220 map tasks to plow through, and 32 of those are executing. So at the moment, I've got 4 jobs per node running. So I'm going to head back into the command line, and we're going to let time pass.
So in your code, you didn't have to specify how many nodes you were running this against, how to do the parallel streaming or anything crazy like that?
Nope. it just uses everything. So time passes and about an hour and a half goes by, and we've got to map 100%, reduce 100%. So great, our job is finished, no errors, which is always nice. And then we're just going to quickly spin back in the job tracker and just see what the state of our job is. So I'll just refresh this page. Now you can see that we've got all 220 jobs are complete, and we've also got 17 failed or killed attempts. This is quite normal within a distributed system. It's not unusual for things to just go, I can't talk to me, it's taking too long to run, the node's lost communication, so that's fine. So I'm just going to quickly go into Cloudberry Explorer and validate that we've got lots of output, and we have, which is nice. So we've got lots and lots and lots of output files. Now, for those of you who, well, each of these files, you're probably going to be able to read this, but it's part-da-da-da-da.gz. When Hadoop's processing the stuff, it dumps data back into what it calls partitions. Now, I've got nearly 220 partitions here because I've got 220 files. When you're processing text, sometimes you can divide these partitions up into more meaningful buckets. So I might use everything, I might have like 26 buckets, one for each letter of the alphabet. There's lots of different ways you can cut up and distribute your data. But in this case, I've just gone for the default setting of just letting it throw one per job. And so this is what we get out the other side. So we've got, attached to this, we've got a timestamp. We've got the file chunk. So when Hadoop's processing files, if they're really big, they can chunk them up. So this is tracking where it's got, which file I'm working with. I've got the message ID that I've generated internally. I've got the author name, and I've got the word. And this is a piece of the genuine output from the process. Although I did avoid one with swear words in it, because there's quite a lot of those. So the next thing is we're going to use Pig to enrich the data. And this happy little chap here in his dungarees here is the official Pig logo. I think it's just become part of the tradition of Hadoop that every new technology has to have a silly name and a ridiculous icon. But it's a query language which shares some concepts with SQL. And I say some loosely because it also has some concepts in common with MDX and also some with languages that I don't know very well. And similar to, for those of you who've done SQL and MDX and understand that it's a bit of a mind-bending jump between the two, pretty much the same story. If you know your SQL and you're trying to get your head around Pig, your brain is going to melt a little bit. It's invoked from the Hadoop command shell, and there is no GUI. And this is not uncommon in the Hadoop world, as I've mentioned. Interestingly, it doesn't do any work until it has to output a result set. So a bit like having a chain of views. If you've got a view, referencing a view, referencing a view, referencing a view, until you execute that last view, it's not actually going to do anything until you're actually asking it to pull back some data. And under the hood, what it's really doing is it's building MapReduce tasks. So going to the core of the Hadoop engine, there's MapReduce tasks. When you write queries and code management in Pig, what it's doing when you execute is it then goes under and goes, right, I need to do this. I've got to work out how to write a MapReduce job that will then execute that. So consequently, it's not always terribly efficient. It's just a little bit more intuitive than actually trying to hand code a MapReduce job. So what we're going to do in the demo, we're going to load the sentiment word lists. So the words that, again, Gavin mentioned earlier, the negative and the positive lists. I picked up a couple of lists of those. Again, I think I got those from Bing Liu. I'm just going to use those as our references to actually work out whether something's positive or negative. What I'm not going to show, but what I also do at execute, is loading the full data that's come out of Hadoop, pre-processing it to get key fields, counting the words in various contexts to get sentiment value, and then obviously dumping the results out to Azure Blob storage. Part of the reason I'm not going to demonstrate that to you is I think that job took about 36 hours to run, so it wasn't terribly efficient, and trying to record it was a bit of a nightmare. So back to the Hadoop command line. You can see there's a whole bunch of stuff I'm going to copy and paste across the side, but I'll hide that. But the first thing we're going to do is we're going to get into the Hadoop command, into the Pig command shell. So we're just going to change into the Pig directory. And I'm going to invoke Pig by typing Pig. And you know that you've actually connected and got Pig functioning because you get the new command line, which is grunt. See, I can't see this happening in the Microsoft world. It's all a bit too po-faced. But Hadoop open source, you can do stupid stuff like this. Okay, so the first thing I'm going to do is I'm going to load this positive words list in. So I'm telling it to load a file from the Azure Blob storage, so that full block rings. I'm telling it to use pig storage, which is just basically text-delimited text storage. And I'm giving the field name. And that's pretty much all I'm doing. I'm just telling it what the file looks like. So the next thing I'm going to do is then I want to add some value to that data. So if I had just a list of words, that's not much use. But what I can do, and this is kind of equivalent to creating an extra column in your table, is I'm going to say, I'm going to rename the word to sentiment word, and I'm going to give it a score of 1 as the sentiment value, because that's the positive word list. I'm then going to repeat this for the negative words. There's my negative words, basically the same stuff. Note I haven't actually had to tell it that it's zipped. The output was zipped. It just picks up, because it's got a zip extension that it recognizes. It'll process the zip data without thinking about it. And similarly with this one, this is my negative word list, and I'm just going to give a -1 as my sentiment value, because this is the negative word list. And then finally, what I'm going to do is I'm just going to stick those two things together. And union. It's a nice familiar term for us SQL bots. And so let's quickly just dump some of that so we can just have a look at what we're producing. So first of all, I'm just going to create a little set that's just a 10-row limit from that set. And then I'll just tell it to go and do its job. And by doing dump show data, what's that telling to? It's just saying dump it to the command screen. So we can get a view. So this is the bit where you can see that it's now just start piling off a whole bunch of MapReduce jobs. And I put it on warp factor 3 because it gets a bit boring. You can see the numbers are slowly ticking up down the bottom. You see this is why there aren't many live demos. Anything with big data takes forever. 75%, 83%. And it's there. So now what we've got a list of words and the scores that are associated with them. So A+ has got a 1, and Two-Faced has got a -1, for example. It's also worth noting, I don't know if I've actually got this on screen, but that process took about a minute to run. So I've taken two word lists of about 4,000 words each, given a value to them, and concatenated them. And that took a minute. And I think it's important to understand that small data operations take forever in this environment because it's geared up to be dealing with terabytes or at least gigabytes worth of data. So there's a whole bunch of stuff that spins up and executes every time you run a job. And for tiny stuff like this, it's a huge overhead. So I'm going to very quickly spin through some pig stuff that I was running through the jobs. So first of all, we've got the load operation. So all this is doing, effectively, is saying, I need to have a file. So I'm bringing in a file from Hadoop file system, and it's a text file, and I need to tell it what fields are. So for example, this is the output from one of the Hadoop jobs, the wrap jobs, and it's saying, well, I've got a file name, which is a text string, I've got a message ID, which is text, I've got the author, which is text, and I've got the word, which is text. So all it is giving it a file description. I've also got some join statements in there. And this is where you start seeing that it's starting to drift away from what we understand in the SQL world. So we're creating a new object called word count sentiment. We're joining this word count flat by the words on the left-hand side to the sentiment on the right-hand side. Takes a little while to get your brain around, but you can do just straightforward join operations. It's just getting the syntax right is a pig to keep it contextual. And then this is a sum operation, and this is where it starts getting really weird. So instead of just saying, I need to get this column, group by this column, and I want to count this stuff, you've got to generate a group, you've got to sum some stuff, and you've got to give it another name, and you've got to do this for each operation, which means that for each of the individual messages that they group together, you've got to trawl through and do this operation here. I mean, you can probably start to understand that it gets a little bit mind-bending trying to write a pig job that makes any sense whatsoever and works. And of course, the worst thing about this is when you get the syntax wrong or you don't quite get the result you want, it can take you an hour to realize that you've screwed up. So the next piece we're going to do is to make the data available. And so what we're going to do is we're going to output this data to Hive. Now, Hive is actually a near SQL compliant language, and I think in the more recent releases, they're getting very, very close to being SQL compliant. So this is actually something that us normal BI people can work with and get to grips with very, very quickly. again, under the hood, what it really does is it issues MapReduce queries. So it's just kind of a translation engine. We're putting a language in, and under the hood, it's just doing some smarts to convert it to a language that Hadoop understands. But usefully for us, once it's into Hive, which is a data warehouse-like structure, it's got tables, it's got columns, the columns have properties, that can then be exposed to ADBC, and we can suck that into our regular BI environments. So what we're going to do, we're going to create a Hive table to reference the output from Pig. And what we're going to do is we're going to use the interactive console. Now, something I haven't mentioned so far is that HDInsi provides a bit of a graphical console. So it's kind of the starting steps of the GUI that Microsoft are trying to provide for Hadoop. And it looks something like this. So we're going to go into the interactive console, which is this beast here. And there's two aspects to it. So first of all, there's the JavaScript console. So this allows us to query the file system, for example, and we can just check that our data is actually run. So we can see that if we go to pig out, where my output was, I've got a bundle of folders, which is looking good, and I've actually got a file coming out the other side. So what I can be confident of is that not just that from the command line it's actually run, but I've actually got some data out the other side to work with. So now I'm going to hop into the Hive console, and I'm going to actually create a table to reference this output so that we've got something that we can talk to that's nice and easy. And it's not too complicated. I kind of zipped through that a little bit too quickly, but we'll have a look at it on screen. So we're creating a table. We're giving it some column names, and we've got, because it's coming from a text file, we've just got some references to build that up. So I'm just going to do a quick count on those. And this table was just literally listing the number of words that came out the other side. So select count star from words. Again, we're getting back into familiar languages now, slightly more comprehensible than Pig is. Again, we need to hit fast forward because everything in big data world takes a little while. There we go. So I picked up just over 4 million words, and that job has taken 36 seconds. And compared to database world, that's slow, but it's not too bad. It's workable. So, again, I'm going to do a quick code review. This one's going to be a little bit easy to make sense of. So I've said create an external table. So what is an external table means that it's a table that's pointing to a file on the file system. It's got a name, words. It's got, as I said, the column names, simple data types, and then some information down the bottom about how the file is actually structured and where the file is. A little bit more comprehensible than Pig. So the next component is then making it look pretty, and at which point I'm going to hand over to my handsome co-presenter.
Handsome co-presenter, goodness gracious. Well, there we go. Well, that was pretty epic. I think we went all the way from C# to Pig to Hive to almost
We
SQL.
covered a bit of ground.
Covered a bit of ground. So all of that is pretty large, but if we rewind for a second, what are we actually trying to achieve? Was to try and answer that initial question. Is can we understand what people are saying and thinking? So all of this technology we've seen so far is fantastic. Okay, the capabilities we're doing are pretty powerful, but it doesn't mean very much until someone's actually able to see that and visualize it without having to write Java command line code to see it. So at this point, I'm going to skip in and basically use Power Pivot and a bit of Power View to show some of those trends and some of those words that actually came out of this exercise. And there's actually one or two things of interest that are worth calling out. So the first thing is, how do we access this? Well, Microsoft have a beta version of their ODBC driver, which speaks to HDInsi. So whether it's in the cloud or on-premise, on the Windows Azure portal, there was that button that James had up there a few minutes back, big download button, and that's where the drivers are. The drivers work with integration services, reporting services, or Power Pivot. And interestingly enough, even with some third-party tools if you really, really wanted to. So what would this look like? Well, here we have good old Power Pivot. And I'm going to go in here and basically pull some data in without having to write some Java command line. So we pick out our data source here. And something interesting that we just need to point out. To make our ODBC driver work, we need to have set up a DSN on the server that we're working with. So I'm going to pick up a DSN, which we creatively called Hive, put in our super secret name and password, which James still refuses to tell me. Save that in there. And then, very similar to database land, we can now go in and pick what we would think of as a database, which is where these tables have been created. So where James had set up those create table statements or create external tables. Once we're in our database, it's actually going to list them here, those three options. So basically the words that had been used, the messages that had come through, and the overarching message sizes. So basically 3 tables which we can now use in our reporting solution. As we would in any other Power Pivot model, we'd select the 3 of them, finish it off, and once it's connected up to the cloud, which takes a second or two to think, it then starts downloading it through to Power Pivot. So think of this through as this is how we would then take all the smarts under the covers and then integrate it with other applications. Okay, I happen to be using Power Pivot right now, but this could be integration services or your broader BI and data warehousing environment. Okay, so without actually going through loading the 26 million messages, moving along. So now it's in a Power Pivot model. So how about we go and build some reports on this? And I'm going to live and breathe inside of Excel for now, just to keep things simple. So I'm going to be using Power View inside of Excel. So let's go and take a look at what we found. So back to our Excel file, good old Excel 2013, and I'm using a bit of Power Pivot as I mentioned. So if we skip across into that Power Pivot model, see I was pretty busy this morning putting this one together. You'll see at the top in our model, we have those 3 tables that have been pulled in. Okay? And very simply, we have a list of actual messages. So we have a user ID, we have the word counts that people said, we have the average sentiment score for those messages, as well as just a generic dump, which I found quite interesting, just a dump of actual word that people have been saying. So if we go take a look at the actual data under the covers, and I was particularly interested in those words, to be honest with you, it's just to see what people had been saying in that 35 gigabytes worth of messaging. And interestingly enough, most people are positive when it comes to the high frequency words they use. So you'll notice there, there were 26 million repeats of like. And of course, with typical data quality issues, I had 2 of them. But anyway, don't worry about that. We'll leave that to the data testing team to figure out. We had to skip all the way down to, I think it's 7 or 8 down before we start getting a high frequency negative word. So maybe these university students that put this all together weren't so negative after all. Maybe over 6 years they were overwhelmingly positive, just to start. And you'll see, from there down it starts becoming a bit of a mixed bag of positive and negative words. So those are just the words standalone. But then if we wrap them up into the actual messages themselves, into what people were saying as a whole message, we have this table here with the authors, and you can see people pick some very entertaining screen names, don't they? And those messages that we had in, we mark in the actual sentiment there. So let's go in and see what our average sentiment is, just for a second. So I'm going to insert, and I'm going to use Power View in here. Could have used pivot tables if I'd wanted to, but I'm a bit of a fan of Power View these days. And yes, the bubble chart was a bit of a hint of where we're getting to. So our average sentiment, you'd think maybe with all those high positive words, maybe people weren't doing so badly. But our average sentiment, if we drag it in, is negative 2.99. So overall, uni students weren't doing so good over these 6 years if we use our methodology. So what about if we just track it over time? Various aspects. Now we're getting into the whole BI aspect of breaking down that number into aspects that make sense. So seasonality is always an interesting thing to start looking at. So we've got our months of the year, sort of Jan to December. And we kind of have, sorry it's a bit small up there, but we have our big negatives sort of August and March, maybe a change of seasons, maybe people break up that time, who knows. Just a thought. But I'm a bit of a visual guy, so if we take that same representation of those numbers and put them on a graph, it just becomes easier for me to understand what's going on. And then if we overlay the years as well, as James mentioned, we've got 6 or 7 years in there. And I found this quite interesting, actually, is that people were generally neither here nor there for a while, until 2009, 10, and so on. And that could be data quality, but I'm kind of saying maybe that's when all the positive people moved onto Facebook. I'm just saying. And all the negative people stayed here. Could just be that. Who knows? All right. So that's kind of one way we can look at this information here. What if we looked at by message sizes? So how much people rented, how many words they put into their messages. Maybe there's a bit of secret sauce there. So you'll notice, and again, in our model, I actually haven't put the individual messages for this reason. Our longest ones were 208,000 words. So people really rented in some cases, wrote essays. But there's one with just 3. So what if people write a short message? Oh, there we go. So if people are short and succinct, they're potentially more positive than people that aren't. So what if we skip across to the other side of the spectrum, right? Kind of just use our interactive filters over there and say, I don't know, the really long ones, maybe 175 up. And you'll notice as it updates, we kind of see that people are actually more negative. So the more people write, the more negative they tend to get, particularly in 2009. No one knows what happened in 2009. I'm not exactly sure myself. But somewhere in July of 2009, someone just got really, really renty with a really long message.
Wasn't there some sort of financial crisis?
Oh, there we go. I was waiting for someone to pick up on that. Thank you. Someone. Thank you, James, for jumping into that. All right, so it wasn't just Facebook. We won't just blame those people. So this is one aspect of the information. But what if we wanted to then enrich this a little bit further? So our title was Big Data, Small Data. So this is my small data piece just for a second. And what I've done over here is I'm going to pull in some information using Power Query. So for those that haven't had the chance to play with this just yet, well worth spending some time investigating this. Effectively, Power Query can speak to a bunch of commercially available and online data sources. And so I was just trying to get some time trending information. So you can see I searched for time trend, something as open as that. And I found GDP per capita in the US. And sorry for the US-centric demo, but the Usenet feeds were from the US. So I thought it would make sense to pull in US information. And just by the by, just for a feel of this, you'll notice that it's actually really easy to visualize those external data sets we can pull in. So I've pulled that one in. Put it in the underlying model. And I've called it something creative like Table 60. But effectively, we have 4 different regions within the US. We have the real GDP per capita over a number of years. So I think it's the last 15 years there and thereabouts. And to drag it into the model is really as easy as taking that table and linking in where it makes sense. So the intersection point for us in this model is year, because we have GDP per year, we have sentiment by year, so I've linked it on that. So let's start a new report and see if maybe there's a link. Maybe there is, maybe there's not. I mean, this is just the data explorer in me. I'm always a bit curious. So we start with our basic measures. So by year, that's what we're joining this on. And we're going to take our average sentiment, as we had, and I'm going to take our real GDP and drag it in there. You'll notice that Power View gets a bit creative. It decides that year is a summing field because I've done nothing spectacular in the model to stop that. So I'm just going to go into year over there and tell it not to summarize because that year field doesn't make much sense as it is. So we're going to strip it out by year. And then we're going to apply 1 or 2 key filters. Because that data set for the US actually has all the states as well as the US, bit of a confusing data set. I'm just going to filter out the high level, just to put the US in there. And then I'm going to visualize this. I looked at that and went, yeah, don't see really much difference. So what if we looked at that slightly differently? So what if we used one of those scatter chart options that we've got in Power View? So we take the same data set. And if my mouse would catch up with me, there we go. We're going to go in and view the same information as a scatter. So each of those years are then going to be represented by one of these bubbles. And maybe there's something there. We sort of have a bit of a scatter over there. But I kind of looked at it and went, that doesn't make much sense to me either, actually. So let's just go and flick the axes. Okay, let's just put the X and the Y in a slightly different place because Power View did it in a way that didn't make sense to me. Maybe it makes sense to you, James, but didn't make sense to me while I was looking at that. So let's just flip that about. And what we land up with, if we take a look at GDP across the bottom, and we look at sentiment up and down, we'll see that maybe there is a correlation between how much disposable income people have and the sentiment that they're actually saying. Right? Maybe there is a link, maybe there's not. So it's just a way, I mean, obviously we could have taken this to all sorts of extremes, but I just wanted to highlight the point that we can use something as simple as Power Pivot, something as complex as integration services, point it to that hive set of tables that we've defined, and then actually generate that and mix that in either with external data or company data to make some really, really rich and interesting views for our business and, heck, for ourselves, right? James.
Okay. Well, thank you, Gavin. I think that was quite insightful. Amazing what you can drag out of data when you start digging around in it. Although correlation may not be causation.
No, not at all. It's just interest at this stage.
Yep, yes. Standard warning applies.
Exactly right.
Okay. So that actually wraps things up. So we kind of blitzed through this session a little bit, but hopefully being quite code intensive, that's probably not a bad thing for you guys. But we're going to quickly review the goals of the session. So the 2% that we wanted you to walk away with, first of all, that you had a bit of an understanding about what sentiment analysis involved. I think hopefully through the 101, you can say that we're just trying to take a block of text and somehow apply some meaning to it. I help you understand what big data actually is. Probably a bit of a big goal for this session, but hopefully you've cleared up a couple of points of confusion for you, or at least cemented in your mind a new layer of confusion to pick up on. Knowing what some of the core technologies do, and I hope that has come across. And if it hasn't, feel free to tap me on the shoulder afterwards, and I'll see if I can either confuse you or clear things up for you, depending on which area you dig in. But importantly, see how big data fits into the traditional BI world. So how we can take the output that we've generated from these fairly gnarly systems with fairly big data and fairly complicated ways of actually pulling that out, and then present it in a nice, simple, visual way that people can really get to grips with nice and quickly. And of course, the big session question. How can I understand what my customers are saying and thinking? This gives you a window into all of the web feedback and the communication that you receive from your customers, and a chance to be able to say, right, I've got this huge and very valuable set of data. How do I extract information from it? How do I actually pull something from it that tells me whether I'm doing the right thing, doing the wrong thing, or somebody likes my products, doesn't like my products? This gives you a route into understanding how you can do that. And with that, that's the session closed. So I don't think there's anything else.
No, that was it. That was it.
That's it. No, there's no related content stuff. So thank you for the session. We're here for questions.
Enjoy the rest of TechEd. Cheers.